All right. So in the last video, we talked about naming angles and classifying them. And then we briefly got into some of the mathematical examples where you used a little bit of algebra. Okay. Um, Today, we're going to talk about angle relationships. And this is going to be important that we know these because there's information provided in some of these um, that help us to make connections that allow us to then find out different measurements and solving the problem just based on their relationship. Okay, um, so there are four, give or take, types of relationships that we're going to talk about today. Some are useful, some are not. Um, but we want to know them all so that when they're referenced, we kind of can envision what they're talking about. Okay, and so we'll start with the most, I would say, useless, and that is just adjacent angles. Okay, um, adjacent angles, ADJACENT. Adjacent angles are just side by side. Okay, um, so two angles that share a side. Okay, and that it is a name. It's a relationship that angles have, but it really doesn't tell us anything. Okay, and so we can kind of draw that relationship out, and so right. So we have a common endpoint here. We'll call that A. B, C, D. And so we can say that angle B, A, C, and angle C, A, D are adjacent. Um, and so that's all well and good, but it doesn't help us mathematically. Okay. I can't do anything with that information. I just know that those two angles are sharing a common side. And so in just knowing the names, BAC and CAD, I know that they are sharing that AC side in each one. So you can see CA and CA in both. Um, that is their shared side. Um, Aside from that, I really can't make any connections. Um, so that's adjacent angles. So when they say two angles are adjacent, that just means they're next to each other. Okay. Um, our next relationship, okay, um, is going to be within adjacent angles. So these do share a common side, or possibly share a common side, and that's going to be complementary. Okay, and I'm going to put a star right here next to this one. He's kind of important. Complementary angles, okay, are two angles. Whoops, brain got a little ahead of itself. Two angles that add up to 90 degrees. Okay, so two angles that are 90 degrees, those are considered complementary. Okay, so probably the most. Right, so we'll stick with our conventions here. And we have A, B, C, and D, right? So I know that those two angles now combine to make a 90-degree angle. Um, And so, right, if drawn in that fashion, obviously they are adjacent. They're still sharing that side, and they add up to 90 degrees. But there are cases, right, where we have something like A, B, C here, which is maybe 58 degrees. And then you could have angle all right. So we have these two, right? BAC and CAD. So these are two different problems. Where now they're not adjacent to each other. They are given measures of 58 and 32. And since 58 plus 32 is 90, we can say that these two angles are complementary. And that's knowing, right, the angle measures. All right, so the next one on our list, again, another star. This is an important one. We've got supplementary. Okay, supplementary is very similar to complementary in that it does involve two angles and they do add up to a certain amount. Whoops. Would help if I could write today. Two angles that add up to 180. Okay. So just like those two add up to 90, now we're looking at two angles that are going to, in essence, form a straight line. Okay. So still going to go with the same convention of names. Okay, so I've got angle BAC here, right? There's that BAC. It's an obtuse angle, and then what looks to be a acute angle on the other side. Those two combining, right, would make 180. And so the same is true if they're separated. We can see that angle BAD, right, BAD, that is a straight angle. And so we know straight means 180. And so if we split that, then we have two angles here with unknown measures, but that we know add up to 180. And that's very useful because that gives us a number to work with, right? So if we know complementary, we know we can work with 90 degrees. If we know supplementary, then we know we can work with 180 degrees. Okay. Our last one kind of has some subcategories in it. So our last one here, and it's going to have a star as well. These are vertical angles. Okay, so these are going to give us some information as well, knowing that we have a vertical angle scenario. Okay, so vertical angles are always congruent, right? That means equal. Vertical angles always congruent to each other. And a lot of times when I say vertical angles, it gets misinterpreted. So vertical angles really just means they are across from each other. All right. And we'll draw a picture so that we can kind of recognize this. All right. So, right, our picture, and it can be any picture you want, but it's just two intersecting lines. Okay, so we've got two intersecting lines. We'll put our endpoint here, and we'll go around and add some names. So B, C, D, and E. All right. So let's talk about a cross, right? So vertical angles, a lot of times people think up and down, which is true, right? Angle BAC is equal to angle EAD, right? So you've got BAC, that's this angle here, right? BAC, it's this angle here, is congruent to EAD. So if we follow E to A to D, right, that would be this one here. And so a lot of times how I'll kind of describe this in class is taking two yardsticks, right? And if you put them together in a crisscross pattern, and no matter how you open or close them, right, it's always going to adjust and keep those opposite angles congruent to each other. So you can kind of like a big pair of scissors, right? You could squeeze if you squeeze these two together, or if you separate them apart, as these two move away from each other, well, so do these two at the same time. So these two opposite angles here are going to stay congruent. But again, just because they're called vertical angles does not mean, right, that they have to be up and down. We are also talking about angle EAB, okay, being equal to angle CAD. Okay, so EAB is going to be this angle here, right, on the outside. We'll put 2. Okay, that's that angle. EAB, right, E to A to B, right? We're following that angle here. And that's going to be congruent to this one on the other side, C to A to D. So it's over here, right? So these two are congruent as well. Okay, so they are across from each other. Now these they don't call them horizontal angles, right? Because vertical is up and down, horizontal is side to side. They don't call them horizontal angles. They're all vertical angles. They all share that relationship. That's why I like to throw in there that we have a cross relationship. Okay. You will also notice, right, if we were to cover up one of these sides, right? So just like we had before, we'll go like that. You'll notice that those two angles, right, that are left, that's BAC and CAD, would form a supplementary pair. Okay, so lots of different things you can get out of vertical angles when they cross. Okay, so these two here, 1, 2, right? Those two right there are going to form a supplementary pair, as well as these two. Okay, those two form a supplementary pair as well. But the big thing here is that we know that vertical angles are congruent to each other, or equal, right? So that way we can use that and make some mathematical sense out of it. Okay. All right. So going to going to look at some different examples here. Okay. And very easy as far as what we've got going on. So we'll start with example number 1, and we'll just talk about kind of what we know. All right. So let's keep it together. All right. So example 1, right? Just going to draw a pattern here. Okay. And we're going to call this 54 degrees. And we're going to go X, Y, Z, right? So basically, right, they want to know angle X, measure of angle X, the measure of angle Y, and the measure of angle Z are equal to what? Okay, and how do we know? Well, we know because it's based on their relationships. Okay, um, so in looking at right this picture, well, I know if this one is 54, because vertical angles are congruent, then automatically I know y is also 54. Okay, so no math there. You just have to know the relationship. All right, so I can pencil that one in as 54. Okay, so if that's 54 and that's 54, well, then these two also have to be congruent. Okay, and you'll remember, right, that these two right here are going to make a 180-degree pair. So 54 and what gives me 180 degrees? And so all I need to do is figure out, right, 180 minus 54. It's going to give me my answer for those other two angles. So 180 minus 54 is 126, I think. Yeah, okay. So uh, that would be the measure of angle X. So if angle X is 126, then that means angle Z is also 126. Okay, and that's all based on just some little relationship things that I know, right? They have to be true. Um, Looking at one more example, we're going to get a little bit fancier. Well, maybe two. Um, okay, so example number 2. I'm going to draw it out, and then I'm going to wait just a little bit to give you some time so that you can pause this and possibly see if you can figure them all out on your own. And then if you can figure them all out on your own, then great. But here we go. All right. Uh, so I've got. Right. And so W Y Z, and that one's going to be 34. Okay. So what connections can we make? Um, well, we need to know, right? Measure of angle W, measure of angle X, measure of angle Y, and measure of angle Z. Okay. Um, and right, we just need to know our relationships. Well, if I look at, right, just this bottom relationship, or maybe some of us jumped right into this relationship with the box, right? The box means what? Well, we should all know that that box means 90 degrees, which means that, right, this and this, right, these two angles are forming a 90 degree, meaning they are complementary, right? So W and 34 make 90 degrees. Well, what is, right, 90 minus 34? And you would simply do the math to realize, right, we have 56. So W is 56. Well, the same is true for 34 and Z, right? These two combine to make a straight angle. And so 34 and something have to equal up to 180. Okay, so 180 minus 34 would be 146. Okay, so I already know those two. Now the rest of them have to come from relationships. Well, a couple different ones, right? If you were to ignore that vertical line there, you have a basically a set of vertical angles being formed by, right, 34 and y are vertical. Okay, so those two have to be the same, or z and y make a supplementary pair. Either way, all right, you're going to get the same answer. and that one is 34. And so lastly, then you would have, right, the x to go. And so we have 34, W, and X, those three combined to make a supplementary pair. Well, 34 and W make 90. So the other part of that to make the supplementary pairs or supplementary trio would have to be 90 and what to make 180? Well, 90 and 90, right? So X would have to be a 90-degree angle, okay? So not a lot of math, right? We just have to know what the relationships are, okay? And so we'll put in play one more problem here, one more example problem. All right, so angle G and angle H are supplementary. If angle G is 3x plus 12 and angle H is I don't know, let's just go with 9x minus 36. What is the measure of each angle? Okay, so there's our problem, right? If angle G and angle H are supplementary, right, which that should spark, that word alone should spark that, right? Should tell us that. So I've got 180. Angle G is 3x plus 12. Angle H is 9x minus 36. What is the measure of each angle? Okay, so what do I have? Well, I have lots of information. All I know is that these two combined make for that. Okay, so I can start with that. All right, angle G plus angle H equals 180. All right, well, if angle G is this, that means those two things are interchangeable with each other. So instead of angle G, I can write 3x plus 12 and added to angle H, same applies, right? Angle H is that, so I can write that in its place, 9x minus 36. Okay, and I know those two equal 180. And again, now I'm just kind of to the basic algebra, combine like terms. 3 and 9x, 3x, 9x, that's 12x. And then I've got positive 12, negative 36. So those combine to a minus 24. So I've got a two-step problem now. Adding 24, adding 24. That's going to cancel it out over here, leaving me with 12x equals 180 plus 24 is going to be 204. And so then I've got 204 divided by 12. And so I know 12 times 10 is 120. 12 times 20 would be 240. So it's somewhere between 10 and 20, a little less, and it's actually 36 less. So we're going to go with 17. Okay. So if x is 17, now I can go back and find the measure of each angle, right? So the measure of angle G is 3 times 17 plus 12. Right, so 3 times 17 is 51 plus 12. The measure of angle G is 63. right? Now, I can do this one of two ways. I can simply put in that 17 into the 9x minus 36, which gives me the answer. Or knowing that these two are supplementary, I already know 180 minus 63 has to give me the measure of angle H. So it's really up to you, right? We have two different approaches to the measure of angle H. So the measure of angle H could be, right, the easier approach, 180 minus 63. 180 minus 63 is, right, going to be, that's 120, so 117. Now, my caution here is that, well, what if you did the math wrong for G? Maybe X is right, X is 17, but maybe you multiplied here wrong, or you forgot to add the 12, right? And you were thinking 51. Well, when you do the subtraction, there's nothing to kind of second check yourself. Whereas, right, if you take the 17 and you place it into the measure of angle H being equal to 9 times 17, minus 36. If you place it in there, right, you do have a second chance to get the problem correct. So 9 times 17, that's 90 plus 9 times 7, which is 63. So 153 minus 36, right, is also 117. So either way, right, as long as you did the math correctly, but at least this way you're giving yourself a chance to correct a wrong if maybe you did the math wrong here. So just be wary of that, right? If you do take the approach of knowing their relationship and doing the subtraction, if you did the math wrong here, it's going to force the wrong answer here. Whereas if you did the math wrong here, you might still get this one correct. And hopefully by then you would know, oh, well, those two aren't adding up. Something's wrong. And go back and check your work. Okay. So any questions, comments, concern, as always, guys, just send me a message and I'll get back to you as soon as I can. If not, again, thank you for your time and we'll keep it going. I'm going to provide you with some problems to work out from today's lesson as well. If you want to, that's fine. It's just practice. But I'm trying to get you ready for the independent stuff to come. Thanks, guys.